Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for today's show. Thank you for joining me. Today, we are going to go over some CAN bus diagnostic tips. That's controller area network. And of course, we cover CAN bus stuff and network stuff quite a bit on this show. I've had lots of case studies. We bring it up with the guests. And of course, it's just because it is so common, right? We have networks on every vehicle and CAN bus on just about every vehicle, especially after '08. It was required for powertrain communications, but we see it across the vehicle, used in body systems and powertrain systems all over the vehicle. We're going to have CAN bus networks. And because it's so popular, because it's out there in so many different applications, even though it is a pretty reliable and quote unquote robust system, we still see failures with it just because it's so prevalent, right? And I get a lot of calls in the shops for network problems. So I figured I'll keep talking about it. The other reason that I thought this was a good time to bring up some CAN bus stuff is because I just finished up the network course for the program that I teach at the college. So the students who are beginners to a lot of this stuff just wrapped up their introduction to CAN bus and vehicle networks. And I just thought it would be a good time to summarize some of the points that I bring up to the students that we work with out in the shop, but I also see technicians struggling with this out in the field. So that's what we're going to do today. I'll reference some episodes, I'll reference some case studies, but there's not going to be anything specific here. This is all general CAN bus tips that will help you if you keep these in mind when you go into your next network or communications problem, specifically pertaining to the controller area network. All right, so tip number one, and this may seem painfully obvious, but I do have a point to bringing it up, is make sure to utilize your scan tool efficiently when doing CAN bus diagnostics. Now, you might say, well, of course, how did I even realize there was a CAN bus problem if I wasn't using my scan tool? And I would agree with you. But what I tell the students and what I'd like you to think about when you're utilizing a scan tool, when you got the scan tool plugged into the diagnostic link connector, think of your scan tool as another module on the bus, on the CAN network. And not only is it another module on the network, but it is an interactive module, meaning that, you as the technician can interact with the CAN bus using your scan tool. You now have a module in your hands that you can tell it what to do, what to send out, how to interact with the network. And it's an extremely powerful tool, right? How else are we going to get the codes out of there, number one? Or how else are we going to find out that we can't communicate with either a specific module, a section of the network, or the entire network, right? Our scan tool is our window into that. So, of course, it's, again, very, very obvious that we're going to be utilizing the scan tool, but don't forget how important it is. And also, you can use this to really point you in the right direction for your diagnostics. Right? If you can talk to a module, like you can communicate with a module with your scan tool, the odds of there being a communication issue to that module at the given time that you're scanning it are pretty unlikely, right? So if you've got, U codes setting in a module and you can communicate to it, that's most likely not the module at fault. Now, of course, we could have intermittent faults where that could be the case. Where it's communicates sometimes and not others, and that will make things more difficult. But if you can talk to that module, like if I can communicate to a module and that's the module in question, or for whatever problem we're trying to fix, if I can talk to it, I'm not going to be busting out my scope, looking at CAN lines, analyzing waveforms, none of that stuff, right? And that's kind of my first step to help me figure out what direction I'm going, is utilize that scan tool. The other thing is that the DLC is not the only place that we can tie our scan tool into the network. And what I mean by that is, think of the CAN bus, and I'll get into some topology here shortly, but think of the CAN bus as the same piece of wire throughout the vehicle, right? It's two strands of wire, but let's just take like CAN high, for instance, and you take CAN high at the DLC, and then you take CAN high at the BCM and CAN high at the powertrain control module and CAN high at the ABS controller. It's all the same strand of wire. It's just going to be stretched out across the vehicle. And why I say that is you can actually jump your scan tool in to any part of the CAN bus. Now you'll need some jumper wires and maybe a breakout box. You can get creative, but you're physically going to be connecting pins 6 and 14 of your OBD2 connector on your scan tool. You can tie this into anywhere on the network. Now, why would you do this? What would be the point of that? I can just plug into the DLC, right? Well, maybe if you are dealing with an open or you're suspecting an open, one thing you can do is jump right to the module in question with some back probes or piercing probes or however you want to make that connection and see if you can talk to the module just by going right to it. Now, of course, there's caveats to that too when we get into terminating resistance, but it's something that you can try, something that you can utilize. Again, our scan tool is just another active module on the network, and we can put it into the network at different points if that's where we're going in our diagnostics. So, and I'll reference back to that as we talk about some of these other tips as well. But scan tool, very important. It's going to point us in the direction that we need to go, and it is an active module on the bus once we connect it, regardless of where we connect it in the network. All right, so my next point is based off of the scan tool, and if we are able to get codes out of the control modules, pay attention to these codes. Obviously, when we're dealing with network problems, we're going to be dealing with U codes. That's the OBD2 format, code format, and U is going to indicate a network problem. Now, again, if you can talk to the module that you're having an issue with, there's not a communication issue with the module, at least not at this time. But maybe you have U codes in every other module that point to the module that you can't talk to with your scan tool. That is definitely going to be an indication that that module is not on the network and it's not communicating. Okay, so easy enough, we can figure that out. But one other thing that I want you to pay attention to with U codes, number one, actually, I don't chase U codes unless they're hard faults, right? Because low battery voltage can set U codes and does set U codes. And so you can be chasing a ghost when really the battery voltage dropped below a certain point for one reason or another. Vehicles with dual battery setups, a lot of Chryslers have these now with the start stop. The smaller battery can be discharged, and when it goes into an auto stop start event, basically kills all the modules that run off of the auxiliary battery. Well, you got a ton of U codes just from that, and has nothing to do with the actual network, but more to do with modules dropping off. I had a case study about a Toyota with a bad body or engine block ground, and we had some modules that were dropping off the bus there too. So I don't chase them unless they're a hard fault or a reoccurring fault, and battery voltage can definitely cause this. But here's the other thing. The main point I wanted to make about U codes is to really pay attention to what they say. And I had an episode about this. I'll put a link in the show notes. Is we can have U codes that indicate invalid data or implausible data. Okay, so it'll still be the same network format code, and there's a reason for it, but it doesn't mean that there's no communication. So let's just pick two modules here to make it easy. Let's say the instrument cluster and the analog brake controller. And let's say the analog brake controller, this wouldn't be the controller. Let's say the wheel speed sensor for the left front is dead. Okay, that sensor is out to lunch, and the ABS now doesn't have an input for the left front wheel speed. Okay, now under normal operation, the ABS controller is going to put this data out onto the network, and the instrument cluster is going to use this data. Well, now that the ABS controller no longer has the left front wheel speed sensor input, it can't put it out onto the network, or it puts out 0 when the other three are moving at 60 miles an hour. And The instrument cluster does not like this data. It doesn't like the missing data, or it can't make sense of the data that it is getting. And so you'll get a code that says either invalid or implausible data. Okay. Why is this important? Because the two modules actually are communicating. There are still messages going across this CAN bus, but the instrument cluster didn't get what it wanted from the ABS controller. There's missing data, or it didn't like what it did get. Okay. Now these can be some tricky codes to decipher. I mean, the example I gave you is pretty easy. You'll probably have a wheel speed code in the ABS controller, and you'd replace that sensor, fix the sensor. But sometimes you can have very strange problems where you don't understand what the message is between these two modules, and that makes it very difficult to fix. So you'll have to do some digging at that point. But the key is to read up on the specific code. Go into the enable criteria, go into the details, heck, go through the flow chart of the code if they give you one, and it may clue you into the messages that are supposed to be going back and forth between those modules. Okay. So really, to sum that up, it's pay attention to the U codes, right? Let them guide you towards what you're trying to fix, right? Again, if you can't talk to a module and all the other modules have a U code, okay, well, we know what's going on there. If you have a bunch of U codes, but you can talk to everything, probably intermittent thing. And don't forget to check for battery voltage, a loss of power to modules. And we can have U codes that indicate there is communication. And this is one that it just really hangs up text. That's why I'm talking about it again. But that there is communication, it's just that it didn't like the data, or is missing some of the data within that information. So my next tip is to understand the network topology of the network you're dealing with, right? CAN bus has a standard format, but manufacturers are free to construct the topology within a single vehicle any way that they choose, or maybe not any way, but there are several different ways that they can set up the networks. And depending on the topology of the network, it is going to change my diagnostic strategy quite a bit, right? And of course, it depends on what I'm going after, right? Maybe a module that's not communicating, maybe it's a complete no-com. But the strategy that I take to try and fix it is going to change a lot based on the topology of the network. So what do I mean by that? I'll give you the most common two, and I just talked with Darren about this last episode. We were talking about the modules, GM being the most common, of course, where they daisy chain the modules. They're basically chained together to make a long strand of network wires. So again, if you had an engine control, an ABS, and a transmission control, just three modules, and they all need to be wired up to the CAN bus. So they'd each have a CAN high and a CAN low, and you'd have two wires basically coming out of the engine control if that was on the left. In the middle, you'd have the ABS with two wires going into the ABS at that connector. You'd also have two wires coming out of the ABS connector going to the TCM, which will have two wires going into it. So you actually have four CAN lines at the ABS module. And those CAN lines are all shorted together, not between high and low, but if you imagine high and high are going to be shorted together within the module, and low would be shorted together in the module. And then the CAN transceiver can receive and input messages off of that. What that means is if you unplug that module, that ABS module, you're basically separating the engine control and the transmission, who are on the left and the right of that module, so that they can no longer talk to each other. Of course, you lose the ABS, but now you've opened the network completely. The other style of network topology is a bus style, where if you just imagine a star, or if you imagine a single strand of wire with multiple legs, if you were to unplug a module in that scenario, you're just going to lose that specific module and nothing else. You won't disrupt the entire network. Okay, so connections at modules becomes critical in GM vehicles because it can take down the entire vehicle network or the entire powertrain network. And the more modules that are on this network, the more possibility there is for an issue there. And it's something you really want to pay attention to on GMs is every module plugged in. But it also makes finding opens, finding shorts a different strategy within GMs. And if you check out the episode on Matt Fonzlo's podcast that I joined him on, he talks about using an ohm meter to find a problem on, I think it was a Chevy truck with a CAN problem. And because of the way they structure their network, the ohm meter is actually really useful. Okay. Now, I'm sure most of us have heard plenty of times the resistance of the CAN bus is 60 ohms because we got the 220 ohm terminating resistors. Okay. And that's great. But that really only matters if you understand the construction of the network, which should include understanding the location of the terminating resistors, right? We want to know where they're at if we're going to try to use them in a diagnostic, right? If we're going to try to find an open in a network using an ohm meter and relying on that 60 ohms, we want to know where those terminating resistors are. Now, sometimes they'll be included in a diagram. Sometimes it won't be. Sometimes it'll be in service information. Sometimes it won't be. And there are oddball ones out there like Volkswagen and Audi, for instance, have the entire terminating resistance, the whole 60 ohms in one resistor in the ECM. That's just the way they chose to do it. So if you disconnect the ECM, the resistance of the network is like 400 ohms or something like that. But anyways, you want to try to understand what you're dealing with, what you're working on in order to use that ohm check effectively. And it may not be an effective test depending on the network, right? Heck, and this was a point that Scott Schotten has brought up in the past, you could have a short to ground on a network. And if you go between CAN high and CAN low with an ohm meter, you'll read 60 ohms, but that network is not going to communicate, right? So it's one test. It's not an end all be all test. It's a test that if it fails, let's say I ohm check a network and I get 120 ohms, or I ohm check a CAN bus and I get 0 ohms, which would be continuity, or I ohm check a network and I get OL, right? That any of those are a problem. And it's definitely a problem if I get those. But if I get 60 ohms, it doesn't mean that the network's perfect. That is something to remember. And again, it depends on the network setup. You can say a lot about a GM network with that 60 ohm reading, where you can't say as much if it's a Mitsubishi, for instance, that uses a traditional bus. You can't say as much about that check, but it all depends on understanding that network topology. Again, I like to think of the ohm check. Well, you could reference it to an ohm check of like, let's say a wire to a headlight bulb, right? And a lot of flow charts will have you ohm check wires. If I ohm check a wire to a headlight bulb and it reads OL, yeah, that's a problem. Okay. But if I ohm check it and it says 0 ohms, that doesn't mean that that wire can carry current enough to light the headlight bulb. Okay. And so it's not that I don't use the test. It's just, I need to understand its limitations. You got to understand the limitations every test. And I talked with Matt about that. I'll link that episode in the show notes so you can check that out. So understand the network topology and utilize an ohm meter, but utilize an ohm meter once you understand how the network is constructed. Hopefully you know where the terminating resistors are, and then you can proceed from there. The next tip is obviously to scope the network. This would usually be in the case where there is no communication on the network or there's no communication to a section of the network. All right. Again, if you can talk to modules with your scan tool, I am generally not scoping the network, okay? Because obviously there was enough communication there. I don't have much of a reason to scope the network unless I'm looking for something intermittent. But in the case where you have no communication on a network, I think getting a visual representation of what's happening as far as voltage levels with a scope is very, very important. Okay. If you're not doing this, you're just guessing, right? Because you can use a voltmeter and you can check the voltages on a CAN bus. And again, yeah, you can use an ohm meter and that too, but you could look at the voltages with your voltmeter set on DC volts and you could see, okay, it's bouncing around on CAN high, somewhere between 2.5 and 3.5, and on CAN low between 2.5 and 1.5, but you're not really getting a good picture of what's going on without a scope. Okay. Now, how do we connect to this with a scope? Well, you can have a 2-channel scope, and a Pico is really good because you can bump up that sample rate, and you can even get specific leads just for CAN bus to clean up the waveform. And you can have a channel for high and a channel for low, and there's nothing wrong with that. And sometimes that's what I do. But the other way that you can do it, actually the way I prefer to do it, and I'll explain why, is using a single channel scope. Okay, so I use my U scope for most of my CAN bus stuff, unless I really get into the weeds with something. I just take my one scope lead and I go across CAN high and CAN low, right? So I'll take the colored lead, I'll put it on CAN high, and I'll take the black lead that would normally reference ground, and I'll put it on CAN low. You get one waveform, okay? Now, there might be situations where you want to look specifically at CAN high or CAN low, if we're thinking there's maybe a resistance or an open problem on one side of the circuit. But for most of what I do, I just want to go across the two. Now, of course, that makes sense when I have a single channel scope because I don't have much of an option. I'd have to bounce back and forth between high and low. But why go across? The reason I'm going across is shown as the difference between CAN high and CAN low, right? That's all a scope lead does, or a voltmeter does, is voltage potential between 2 points. And I'm just looking at the difference in voltage potential between those 2 points when I'm connected across CAN high and CAN low. Now, this will actually draw a really clean waveform compared to each single channel, especially on vehicles like GMs, okay? Because what we're seeing there is just the difference between high and low. And the reason that they use a twisted pair and 2 wires and a high and low system on a CAN bus is to reduce the effect of electrical interference, right? There still is electrical interference. And take a look at a GM CAN bus on a mid-2000s, if you don't believe me, and look at each high and low individually. You'll see it. It looks like garbage. You're like, how can anything communicate on this? I was looking at our school 2009 Chevy Silverado, and it looks like absolute trash when you look at each individual channel. But when you go across, you're basically eliminating that noise because the electrical interference affects both the high and the low the same. So the difference between them never really changes, right? At one given point, right? So if we're transmitting and we're 3.5 on high and we're 1.5 on low, but we get a little bump of voltage, both of those wires will bump up the same amount. The difference between them never changes, right? And so when we're going across, the scope is going to be showing us just that difference, and it never changes with the electrical interference. And all that's to say, that's what the computer sees. That's what the computer's looking at. And that's how it's able to accurately translate the voltage pulses and the data packets on a CAN bus, regardless of electrical interference. So it's what we can do. Okay. So again, going back to this, utilizing the scope, looking at the data network, I like to use the scope here because it gets rid of all that noise that could send you down a rabbit hole. And that's actually my next tip, is to not overanalyze the waveform using a scope. Of course, I said use a scope, otherwise you're guessing, but at the same time, don't overanalyze a waveform. And I found going across the two really helps me to do that because it will clean up the waveform and show me what the computer sees, okay? Now, you may still see something where like, I don't know, there's like a little bump of voltage there. Maybe it's something, maybe it probably isn't, right? I have spent hours over analyzing CAN bus waveforms because I thought that was the issue when really it was something else. Probably one of the times it was, an issue with some of my equipment, issues with modules, whatever it is. Don't over analyze it. When there's an issue with the CAN bus and you've hooked up the way that I recommended, just going across high and low, you see it. It's obvious. It will stand out very, very clearly, right? If we have a module that's corrupting the network, just putting out nonsense, you're going to clearly see it using the method that I explained there. Now, again, there is a time and place to go individually to high and low, but that's easy enough to do even with a single channel scope like the U scope. Just move your ground lead over to actual ground, and then you can move your colored lead between high and low and look at each one of them individually. But like I said, 90% of my CAN bus diagnostics, I use my $160 U scope, and it works just fine for that stuff. But you can go Pico and you get real detailed. Just don't overanalyze because you can go down the rabbit hole on that. Okay, so for my next tip, let's say We've got no communication with the network. We're not able to talk to anything with our scan tool. So our scan tool at that point has kind of become useless. We've hooked up our scope and we have found one of two things. Either there is a short, maybe a short to power, maybe a short to ground on the network, or there's corrupted messages being sent out onto the bus, just garbage noise, electrical signals that no one else can talk on the bus. So how do we go about finding the source of the short or the source of the corrupted messages? Now, this could be in a module if it's a corrupted message or a short. I guess the only source of a corrupted message would be a module that I can think of. Maybe there's an exception to that. Of course, there's aftermarket accessories that could be tied into the bus. I've seen that before, so it won't be on the diagram. You could still find it using this method. But a short obviously could be within a module, but it could be a wire itself, or it could be somebody that installed some running boards on a van and put some big machine screws up through the body and went straight into the CAN lines, right? That's a short to ground. But anyways, how do we go about finding this? Because the challenge is that this CAN bus can stretch across the length of the vehicle in some cases, right? A Chevy Cruze is going to go all the way from the very front of the car all the way to the very trunk backside of the car for the fuel pump module and everywhere in between. So this is a large section of wire that we've got to try to find a fault in, whether it be a short of some sort or a corrupted message from a module. Now, what do you do here? Do you go through and disconnect each module one by one? I guess that's an option. Well, it could still be, or if it's short to ground, it could still be a wire somewhere. So you just went through the trouble of disconnecting every module and you didn't get anywhere. You can pull fuses to modules to try to take them off the bus. This isn't my preferred method, and I'll explain why as we proceed, but it is a method that I've heard people use to see if the module that is corrupting the network, if you take away power from it, if it cleans up. But again, not my preferred method to go this way. Here's what I like to do, and I didn't come up with this. I learned this going to training courses, is to divide and conquer the network, especially if it's a large one, right? If it's a smaller CAN bus, there's only a couple, 2-3 modules on there, like older vehicles. It's not going to be as difficult, but let's say we've got 10 modules on this network. It's a pretty large one. How do we break this down into smaller sections? Well, that's exactly what we're going to do. We're going to divide and conquer the network. We're going to split this network somewhere, and we're going to figure out which side of the network our problem is on, right? So if it's a short to ground, this is pretty easy. We could take a test light, power up the test light. We touch it to the CAN network. It lights up. Okay, we know we got a short to ground here. Now let's go to a dividing point in the network. Now, if this is a GM, a module is a great place to do this because you've got, I'm using this with air quotes, an in and an out to that module. I realize messages are going to be going both ways, but you could test each side of the network from a module connector after you've unplugged it, because you've just separated the network into two sections. And I'm going to reference my diagram. I'm going to find something that's easily accessible and hopefully somewhere towards the middle of the network so that I can figure out which direction to go. You know, do I go closer to the DLC or do I go closer to the fuel pump control module in the trunk? What side of my network is there an issue? Now, if it's not a GM style daisy chain, if it's your traditional bus style, you might have to find a connector in line somewhere and disconnect that so that you can test both sides of the connector. You're going to separate that network. Now, I have a few sub tips for this if you're going to try to find a connector to separate the network. Number one, if you're using redrawn diagrams, okay, which are nice because a lot of times they'll sum up the whole network on one page for you or 2 pages, which is handy, and I use that a lot, but they very, very often do not include the connectors, or at least all of the connectors in the network. They'll just show you wires running from one module to the next, and they don't show you any of the inline connectors. You may have to reference the OE diagrams just to find that there is a connector that I can access to split up this network. So that's tip number one. Tip number two here for the divide and conquer method, where we're splitting the network up into smaller sections, is if you find a connector and you unplug it, keep in mind that your two CAN lines that you're separating on that connector are not the only things that you're unplugging. Now, there is a ton of variables here depending on what you're working on, but here's something that can happen. Number one, the connector you disconnect could have a power or a ground that goes to a module that maybe is the source of your problem, right? Pretty unlikely that that would happen, but it's possible. And here's another one. And this actually did just happen with one of the students in the shop when we were going through some CAN bus diagnostics. There was a connector that was unplugged for this purpose, to divide the network and to test each side. Well, what we failed to realize at first was, we realized there was CAN lines in this connector. Well, there was more than just two CAN lines in this connector. This connector, and this is Ford, that's a 15 Ford Fusion. Why they decided to do it this way, I don't know. They had CAN lines that went into this connector, went up onto a harness, connected to 3 or 4 different modules, then came back with 2 separate lines to the same connector, and then proceeded to go to the rest of the network after that. So it like looped away from this connector, came back, and then went through. And we failed to realize there was a second set going into this connector. And we were trying to find an open on this one, actually. We were utilizing the terminating resistors, trying to find an open, and it really, really threw us for a loop because we didn't realize there was multiple CAN lines going. And we basically made 2 separations of the network here, and we didn't even realize it. We thought we only split it in 1. So really what I'm getting at here is if you're going to utilize a connector to separate the network into smaller sections, just be aware of what else is on that circuit, okay? So worst comes to worst, heck, you could always cut the wires and then repair them after. I don't always recommend that, but if there's not a suitable connector, or you're worried about what else you're going to be disconnecting, cut the wires, depin the wires, whatever you have to do. But we're breaking this network down into smaller sections and then testing each section. Okay. Does the network messages, do they clean up after I disconnect this leg of the network or this part of the network? Does my short to ground go away once I disconnect this side of the network? Okay, let's go after the other one. And you just keep dividing down smaller and smaller until you're working with a single module or a single leg of the circuit. And it saves you so much time as opposed to unplugging modules one at a time, or tearing up the harness for the entire thing and ohm checking wires and all this stuff. It's such a huge time saver to do this. To divide and conquer, I would definitely recommend doing that. Just be aware of what you're unplugging as you're unplugging connectors. All right, now let's say we're dealing with some corrupted messages, meaning that the network's not open, it's not shorted to ground or power or anything like that, but the messages that we see coming out of the network are just garbage. And let's say we divided up the network and we found that these corrupted messages are coming from a single module. We've identified, okay, if I unplug this module from the network, it all cleans up and we're good to go. So just replace that module, right? Make absolute sure that you load check the powers and grounds going to said module that is causing the corrupted data. I have found on more than one occasion, actually pretty frequently, a poor ground or a poor or missing power feed to a control module causes it to pollute the CAN bus. I've been seeing this pretty frequently, actually, with grounds to modules. General Motors comes to mind. Definitely seen a few of those, but I've seen others as well. And repairing the ground is what fixed the car. If we were to pop another module in there, it would do the exact same thing. It would still be polluting the bus. So before you just call the module, right? Okay, I unplugged that ABS. That's it. Let's get an ABS module for it. Make sure to check the powers and grounds. And going back to the method that I mentioned where people will pull fuses in order to disable modules. Again, I'm not saying you can't do that. I'd be very cautious doing that because if you're losing a power feed to a module, there's a potential it could pollute the bus, because I've seen missing fuses cause modules to pollute a bus. It does happen. So just something to keep in mind there. I don't prefer pulling fuses in order to do this. I would rather, divide my network up, find the module, unplug it, verify, okay, my network cleans up on my scope, and then I'll check the powers and grounds to the module to make sure that they're not causing this to happen. One of the other things that you don't want to forget, and this is actually kind of going back to the divide and conquer, is check in your diagram and your service info to see if there are splice packs, any type of splice pack that is used. Not every manufacturer uses these, but some do. Some of them are hard to find, but a lot of them are up underneath the dash. Chrysler uses something called a star connector. Volkswagen has their version of it. I've seen it on Ford vehicles. I've seen it on Mitsubishi vehicles. GM generally doesn't use it on their CAN bus. Of course, they do on their single wire networks and their class 2 stuff. They always had splice packs. Can't say I've seen too many on CAN bus setups. So not every manufacturer utilizes a splice pack, but if they do, a splice pack is a great place to just pull legs off of the network individually and to do your divide and conquer testing there. So don't forget about splice packs. They're really, really useful. Utilize your diagram and the component locator search function within service information to find where they're at. And hopefully it's a somewhat easy location and you can separate up that network pretty easily using that method as well. Okay, that's going to do it for my CAN bus diagnostic tips. You might have known some of those already. Maybe you're reminded of something. Maybe you learned something new. Hey, if you've got anything else that you'd like to add to this, hit me up on Facebook. Shoot me a message. Let me know. Is there something I forgot? Something I missed? Something that you do that's not widely known that makes your diagnosis of these systems more efficient? I would love to hear about it. Reach out to me. Let me know. Heck, we'll even get you on the show if you want. But other than that, just like to thank everybody for listening. And let's all get out there, start fixing the world one car at a time.